This is section 9.2, problems 1, 2, 3, and 4. Here's number 1. In the least squares line, y equals 5 minus 8x, right, a plus bx, what is the value of the slope? Right, now look, the slope, we're just writing it a little differently than you've seen before. Back in algebra, we wrote mx plus b. This m, that's the coefficient of x, that's the slope. So in our equation, we've got y hat equals 5 minus 8x. That is the coefficient of x, so that is the slope. So in the least squares line, what is the value of the slope? Negative 8. Now here's what the slope tells us. If you have the slope as negative 8, the slope is always a fraction, right? It's always a fraction. The slope is the vertical change over the horizontal change. Always a fraction. Now I can write negative 8 as a fraction if I write it as negative 8 over 1. So that means that if I am somewhere on the line and I make a 1 unit change, right, a 1 unit change in the horizontal, positive 1, so I go this way, I go down 8 units. Right, 8 units down. Right, so this, if I increase the input by 1, the output goes down by 8. Now, what are they asking us over here? When x changes by 1 unit, exactly this. Y changes by what? Well, we just said y is going to decrease by 8. So do we have that? When x increases by 1 unit, y, no, opposite. When x increases by 1 unit, y decreases by, that's not right. Y does not decrease by negative 8. That's a double negative. That means y goes up by 8. What is this? I don't want to decrease. When x increases by 1 unit, y decreases by 8 units. That's it right here. You know, this is a little tricky. Be careful here. All right, so we got number 1 done. Question number 2 says, when we use a least squares line, like this one up here, all right, we use that line, to predict y for x values beyond the range. Right, now here's what they mean. We've got a scatter diagram. All right, say we've got a scatter diagram, and we're going between A and B. Right, as long as we pick an x value in here, that's going to give us our somewhat accurate results according to our line. Now, as long as I'm inside, if I predict inside, I'm interpolating. If I predict outside, I'm extrapolating. Right? Inside, x, outside. So what do we got going here? So we're told that when we use a least squares line to predict y values for x values, predict a y from an x, beyond the range, all right? So that means beyond the range, so we're out here, okay? We're out here. Beyond the range found in the data, are we extrapolating any concerns about such predictions? Well, let's see what we say. Well, we're not interpolating, right? I can get rid of this one because I'm going outside. I can get rid of this one. This one says we are extrapolating. Extrapolation is dangerous because the pattern of the data may change. Sure enough, what is this? We're extrapolating, but there's no concerns. No, that is not the case. It could be that we have something like this. All right, suppose our data looks like this right in here, but then outside it suddenly turns around and does something like this, okay? So as long as we're inside here, we can use the line, but if we go outside, maybe the line doesn't fit anymore. So let's go with this one right here. We don't want to extrapolate. Now in question 3 it says, in the least squares line, y hat, our estimated value of y equals 5 plus 7x. What is the marginal value of y for each unit change in x? Okay, the marginal is just the slope when you change 1x. All right, so the slope here is 7. Write it as a fraction, 7 over 1. So if you make a 1 unit increase in x, y goes up by 7. So the marginal change here is 7. And then finally, it says, number 4, If two variables have a negative correlation, okay, right away, negative correlation, I think that. Is the slope of the least squares line positive or negative? Okay, well, it's going down, so this is going to be negative, right? It's a negative correlation. It goes down. The line goes down. That's it.